Hi everyone. No quiz today, and some people might be thinking I will do that to you, and it so happened that today I didn't. Might be a quiz on Friday, who knows? Or maybe not. I wanted thanks for coming anyway. It's going to be useful stuff. I wanted to talk a little bit more about test cases. So there is a taxonomy, so meaning just a way of separating out into categories of test cases. This is not necessarily super useful. This is not the kind of thing where I would ask you, oh, is this an error case or is this an edge case? But it's on a midterm. But it's a good way to think about how to come up with test cases on the project. Right? So you have your typical cases. So typical cases would just be typical situations where you're using the function. You would have error cases. This is more prominent in languages other than Python. So an error case would be a situation where the input is in some way invalid, and the function's job is to in some way let the person who called the function know that they did something wrong and that the format of the input was wrong. So an example that's fake would be if you give a string when what's expected is an integer. There could be situations where that's an actual example. In our case, in our project, for example, we just assume that you give the right kind of thing to the function, because if you don't assume that, it never ends. Like, what if it's a string? What if it's some third kind of object? It just doesn't end. We don't do testing like that. Edge cases would be any cases where the output might change if the input is changed just a little bit. So it could be a situation where if you change the input just a little bit, then it's an error case. For example, if the function is expecting just positive inputs and you input a 0, that's an edge case, because a negative in that case might be considered an error case. Okay. It could also be just a situation where the input would change, not necessarily from error to not error, but from any one thing to any other thing. That might also be an edge case. Again, there are philosophical issues about what's an edge case, what's an error case. Does something count as typical or does it count as an edge case? This is not something that I care deeply about. This is more a system for coming up with good test cases so that you get good test coverage. What's test coverage? So there is a formal definition. So the percentage of the lines of code that have run when you've run all of your test cases. So 100% coverage would mean that every line has run. Right. Of course, if the coverage is not 100%, there probably are bugs, because if the coverage is not 100%, that means that you've written some lines of code that you've never run and you've never checked that they produced a correct piece of output even once. Could work out, probably wouldn't. However, a coverage of 100% doesn't guarantee correctness, right? So you might imagine that you've run every line of code and it even produced the output that you expected, but nevertheless, you didn't consider all the possible ways in which each line of code could be run. So 100% coverage is necessary probably in order to be sure that your code is correct, but it's probably not sufficient. So there are tools to automatically measure test coverage. They're too complicated to use in the context of ESC180. You can just eyeball it, but test coverage of 100% is definitely something to aim for. Because again, if you run code and you never run it, what's the probability that it's correct? Not very high. Yes.
In industry, do you like unit test 100% of your code or like how do it?
I mean, again, 100. So the question was in industry, do you test 100% of your code? So it's necessary, but not sufficient, right? If you only run the line the once with one particular input, that definitely doesn't mean that the line is actually correct. It just means that it was correct the once. Okay, so yes, and much more than that. That's actually kind of the topic of the next slide. So in industry on large projects, you have people whose job it is to basically find bugs by trying all sorts of test cases. They're called, I think not in Canada, you can work in QA quality assurance, but not be a professional engineer. Of course, in Canada, the only way you can call yourself an engineer is if you're a professional engineer. So a QA person in Canada would do something like this. This would probably be an American, not a Canadian, who doesn't care about Canadian laws and regulations that prohibit the use of the word engineer. Anyway, the idea is the job of a QA engineer is to try and figure out how to break the code by inputting all sorts of test cases, like something like this. And to your question, even if a QA engineer tried all of those things, it does not mean that the real customer is not going to encounter errors. The converse, however, is true. If you don't test your code, it's extremely likely to be wrong. And in project one, of course, you are your own QA engineers in training. Not even engineers in training. I think you get to be an engineer in training after you graduate. Okay. So let's look at the example from last time to kind of see how to think about this in practice. So this is the example from last time. So what do I need to think about when I'm trying to test this code? Well, I just want to think, first of all, of what are the typical cases. So I definitely want to try and test what happens when I jump. I definitely want to test and see what happens when I rest. I probably want to keep the tests as small as possible, because if I see that this is not what I expect, I then need to go back and think hard about which line caused the problem. On the other hand, if I keep my tests be small, then if I detect a problem, I can go and fix it right away, right? So what would I do? Well, at the very least, I would say, perform activity, jumping, print current headings, and then I'll reset and do the same for resting, and reset and do the same for swimming. So whatever, 130, and this is 0. And then I'll do, again, reset this, and this would be 2 headings, right? So those would be the simplest typical cases. So I would also want to check that it does actually work when I do 2 activities in a row. That would also be a very typical case, right? So what I'll do is I'll reset, and in project one, you can reset very conveniently using initialize. And I'll perform activity swimming. And maybe I'll perform activity swimming again. All right. So swimming gives 2 headings per minute unless there was a non-rest activity less than an hour ago. So in this case, this would be 0 headings, and this would be 2. what I would suggest doing is printing out test one. So you don't have to, but that's kind of one way that you could do it, is you do like test one, you do test two, you do test three, and you do test four. And that way you know which outputs correspond to what. So here I put in the expected number of hedons as a comment. That's not super convenient because I run this and I get, 13, 0 to 22. That's just incorrect because this is the old version of the code, right? So I can then go and look and see that the 22 is incorrect, and I actually need to fix the code. But it wouldn't be very convenient if I have many tests, right? So one thing I might do is I might just do an if statement, right? So I could say if current hedons is not equal to 13, something like test one failed. I might go even one further and say my expected output here is 13, and then I don't have to put it in the middle, but rather I would change the test cases like this by just changing this number here. Make sense? So it's up to you exactly how you set it up. Again, there are ways to automate it completely. In fact, what Gradescope does behind the scenes is use one of those ways. However, setting this up is too complicated for project one. So if you like, you can do it manually. This is one of those situations where if you know the test cases and you know the outputs, you can just tell ChatGPT, like, here's how I want to test. And here are my inputs and here are my outputs. Generate some test cases for me. That's actually a very legitimate way to use ChatGPT, and it would work really well. Make sense? Doing your homework for you is prohibited, but that's just testing. That's completely fine. All right. So this is kind of thinking about typical cases. So, resting, swimming twice in a row, maybe swimming and resting. So those would be typical. So if I want to try to come up with edge cases, I would think, okay, so what are situations where I'm about to change the output, but not quite? Well, so here there needs to be a non-rest activity less than an hour ago in order for swimming to not get 2 hedons per minute, right? So what I might do is I might say, okay, so let me copy the good one here. Let me name it test 10. And what would I do? So I would do jumping for 59 minutes. And that's 59 hedons. And then I'll try to do swimming for 1 minute. And that should be 0 hedons. And my expected output would be 59. Again, the code is before it was fixed up last time, so it would actually fail. Does that make sense? Questions about this? All right, again, kind of don't overthink it in a sense of what's an edge case, what's a typical case, whatever. Think about how do I run all the lines? So in this case, there's not very many lines to run. So it was just like, if I tried jumping and if I tried swimming and if I tried something else like resting, then I have 100% coverage already, right? busy mom. So that literally was my mom. So okay. Sorry about that. So other than that, just think about all the possible situations of how you would use the code typically, and maybe think about when would the output change. So equally, you would probably also want to see, what happens when it's 60. So when it's 60, then you're supposed to get the hedons. So here, I just copied and pasted, and I'm changing test 11 here. So again, you can be like even clever about it and only type in 11 once by, for example, setting n to be 11 or something. And then I'll try 60. And this would be 60. So the comment would say 60, and then the one would actually get 2 hedons. So the expected hedons would be 62. You can also try 61, but if test 11 passes, then the next one is probably superfluous. Okay. Is that making sense? Questions about this? All right. So yeah, so this is kind of a famous picture. So this is from 1948. First actual case of bug being found. So this is like on a Harvard University computer in 1948. So there is a legend according to which this is the source of the word bug for mistaken software. Well, this is evidence that that's clearly not the case, because it says first actual case of bug being found, implying that there were metaphorical bugs before. But anyway, a cool piece of history. So this would be a moth that was stuck in apparently relay number 70 in the whatever thing that they got going there in 1948. So all right. So let me check how Discord is doing. Is it true that I went to Victoria College? No, it is not true. So, okay. So okay. I know my anxiety lore. Wait, did you do the authority thing in Praxis yet? Oh, okay. Yeah. All right. Okay. Okay. All right. Is it like a good question? I'll wait. Okay. Top 20. Okay. Do you ever well, it's there is like a serious answer to that question, which is, well, no, not really. So if you are, as I am faculty at U of T or whatever, you have friends who are faculty at Princeton or whatever, and those friends are like, have always been much smarter than you. You have gotten over it, and that they're also, like are envious of their friends who are potentially even, or not friends, or like Gauss or whatever, who are like even smarter. So yeah, that's just how life goes. You're never satisfied, or you shouldn't be at least. So okay. So let's talk about repeated computation, or as it's known, loops. So far, every piece of code that we saw, with one tiny exception, only ran once. So loops are really a way to make computers useful by repeatedly running code so that you can compute things that are not straightforward to compute using just a calculator. So here's the simplest possible way to repeatedly run a block of code. So if you want to run the block over there, and times, one way to do it in Python is for I in range n. So n would be the number of times that you want to run the block of code, and that's what it is. So each time the block is run is named an iteration, from the Latin iterum, which I found out this afternoon. This is not on the test or anything. Is from, iterum meaning again, which goes back to the Latin is, which actually goes to Proto-Indo-European for the. So basically thing. So iteration means thing that you repeat. Okay. So all right. That was just a bit of fun. So let's do the simplest possible example. Just do n iterations. So repeat the same thing n times. So I'll do my main block. By the way, so here, the reason I'm doing this, so this is called live coding when you code in class, is I would like for you to code along with me and experiment with the code along with me. You don't have to. You can pick and choose kind of what suits your learning best, but probably trying things on your laptop is a good idea. So, all right. So here I want to repeat something n times. Let's say the n is 100. And I'll say for I in range n. And the thing I'm repeating is I'm just going to print something. What should it print, Discord? Something appropriate. I have no idea. So, all right. Rigor with a Canadian U. Okay, so I've ran it and it's printed rigor 100 times. By the way, so this is an aside, but you don't have to take my word for it. I'll copy and paste this and I'll put it in a new file in Paizo, and I've pasted it. And as you see, it does take up 100 lines. So yes, it's printed 100 times. We'll see other ways to verify this shortly. All right. So all this does is just print the word rigor n times. So let's make a little function just for fun. So print the string s n times. Not the simplest way to do it, but why not? So I'll say for I in range n, and I'll print s. So this is a function with a side effect, right? Its job is to print the string s 100 times. So now we can be rigorous more efficiently. So commenting this out, Control R, and calling print n times could be 1,000. And we'll do authority. Amazing. All right. Questions about this? Okay. Yes.
The range is very like
Yes. So the question was, is the range computing some kind of object? The answer is yes, but it's in fact, confusingly, it's called an iterator, but we're not going to get into this. Okay. Okay, guys, so please go to one of the troll channels if you want to joke around, because I'm checking this for questions as well. Unless it's like really funny jokes, in which case keep them here. So, okay. So let's do another example. So what's the simplest thing that you can do that requires repeated computation? Well, it's arithmetic, right? So what is multiplication really, right? So A times B is A plus A plus A plus A and so on, B times, right? So of course, we do have a multiplication operator in Python, but just for the sake of the example, let's do manual multiplication, where we use repeated addition in order to compute something like A times B. So what would be the job here? So I have A. For concreteness, let's make it 3. And I have B. For concreteness, let's make it 5. So what I want to do is I want to compute 3 plus 3 plus 3 plus 3 plus 3. Right? So I'll rewrite it a little bit as 0 plus 3 plus 3, 3 plus 3, and so on. Okay. So now how do I do that? Well, one way to do it is to say initially S is going to be 0. Well, I already used S for something else. So it's my sum. So initially my sum is 0, and then I want to add 5 into my sum, 3, sorry, 5 times. So how can I do it? So I'll say for I in range, initially I'll just say 5 so that I don't get confused. S plus equals 3, which if you remember, sorry, I named it my sum, which if you remember is the same as my sum is equal to my sum plus 3. Make sense? So what this does is it says my sum is 0, and then my sum is 0 plus 3, and then that plus 3, and then that plus 3, 5 times. So at the end of it, my sum is going to be 15. Let me rewrite this in terms of A and B. So I'll again reset my sum to 0, and I'll say for I in range. So here I'm doing A plus A plus A. So I'll say in range B. Of course, because A times B is equal to B times A, I could do it the other way too, right? Say my sum plus equals 8. Okay, so let's trace it. So I put a breakpoint here. And now my sum is 0. So here it would be convenient to look at the workspace. So my sum is 0 over here. A is 3, B is 5. Can people in the back see this? Can you not see this in the back? Anyone? You cannot. You can. I can't actually change it. So we'll have to make do, and I'll just query over here. So my sum currently is 0, A is 3, B is 5. And here what's going to happen is line 22 is going to get repeated, 5 times, because we say for I in range B, that means repeat this block 5 times. So the first time we were over here, so for the people who do see it, my sum is about to become 3 because we added 3. Here I can query whether my sum is 3 or not. It is. So the next time my sum has become 6. And then the next time this runs, my sum will be, 9, and so on. I'll press continue to just go until the end. And at the end, my sum has ended up as 15. Okay, so here I was just experimenting with stuff in the main block. Now that I got it down, I can write it as a function. So this is not a very efficient way of doing multiplication. That's not the point. The point is the example. So I'll say for I in range B, my sum plus equals A. Initially, my sum should be 0. And at the end, I'll return my sum. So that's multiplication. Does that make sense? Questions about this? No? Yeah. Yeah, so the question is, what does the I do? And the answer is right now, nothing at all. So right now, the way we think about it is this is just a way of repeating the block n times. I could in fact be any other name. It has to be a name. Sometimes when people want to emphasize the fact that this really doesn't matter, I won't do it. But sometimes people use underscore instead of I. Underscore is a variable name just like any other, like I. You can say underscore equals whatever. But this is just kind of to emphasize that I'm not going to use it. In practice, you could, right? So here, I literally have a variable whose name is underscore. That's fine as well. But just to emphasize. Okay, so right now, the I doesn't do anything. In the next couple of slides, either today or on Friday, you'll see how I gets used. Okay, other questions? All right. So let's do another example, and that's going to be very similar. It's just going to be exponentiation instead of multiplication. So what's exponentiation? Well, a to the power of b is what? It's the same. It's like a times a times a, and so on times a. Again, b times. Just like here, I added 0 because I needed to put something initially in my sum. Here, I'll put what? 1, because 0 wouldn't work, right? 0 wouldn't work. Why wouldn't 0 work? Yes. Yeah, because like if I keep multiplying 0 by a, it's gonna stay 0. On the other hand, I multiply 1 by a once and it's a. I multiply it by a another time and it's a squared and so on. So that works. So let's go and copy and paste my mult and just change it to my POW. So this would be my power. And this would be a to the power of b. And I'll just name it res. I guess you could name it like my product or something. And initially it's going to be 1. And I'll multiply by a every time. And I'll return res. So, of course, you could think about it from first principles. You could also think about it as, if you understand my multiplication, well, my power is exactly the same thing, except with times instead of plus. Let's trace it just to be sure, just the once. So I'll comment all of this stuff out. Control R. And I'll compute. So it's kind of annoying to do 3 to the power 5 because that's 5 times. So I'll instead do 5 to the power of 3. So I'll say my power, and I'll say 5 to the power of 3. And I'll put a breakpoint here, and I'll run this. And now I'm stepping in. So I'll query A. A is 5, B is 3. So this means repeat, in this case, B times. So repeat 3 times. Res is equal to res times A. Right? So res initially is 1. And then the first time res is going to become 5. And then the second time it's going to be whatever it was times 5 again. So 25. And then the next time it's going to become 125. And we're done. So res is 125. We are about to return res. So that it is true that 5 to the power of 3 is 125. So the value of this is going to be 125 because this gets sent over here and it's going to get printed. It's the last line in the code. So I'll press continue so that a new file does not get opened up. And that's 125. Okay. Questions? All right. So to your question from before, you can use the value of I. So in fact, if you repeat the block n times, what's going to happen is the first time I is 0, and then I is 1, and then I is 2, and then I is 3, and so on, up until n minus 1. So let's do an example. So how would I do it? So first, I'll just print 0, 1, 2, and so on. So I'll say, the value of I. This is, of course, just a string. I could say anything. And then I'll print I. So if I run this, it's going to say the value of I is 0, and then 1, and so on, up until 99. So you'll notice that this did repeat 100 times, because if you start from 0, you end at 99. The total number of lines that got printed is 100. Yes. Well, I'll get to that. Okay. So that's kind of the basic thing. So let's kind of make a function again just for fun. So I'll name it like tell n times, and then message. And here I'll just do kind of the same thing. So I'll say for I in range n. So I'll do like, I'm telling you for the, and then I, and then th time, comma, and then message. So there needs to be a comma after the quote as well, right? So it's the same kind of thing. It's just that I'm printing the string I'm telling you for the, and then I print I, and then I print the message, right? So let's print some valuable message. What's a good one? I did not supply an n. How many times? I think 15 ought to do it. All right. So you get this nice kind of output here. Does this make sense? Questions? Okay. So one question from before was, it's all well and good in like a computer science kind of audience to start counting from 0. That is in fact what we do. But other people maybe don't know about 0 times and stuff. So what if you want to do, you know, first and second and third and so on, right? So let's do that. So the simplest thing you can do is instead of printing I, you can print I plus 1. So that way, where you would print 0 before, you're now printing 1. When you print 1, you would print 2 and so on. And where you would print 99, you would print 100. I did not call talent times 2. So that's still the old version, but that's okay. I wanted to do a total of 300 during this lecture anyway. Okay. So one might object that 1th time and 2th time are not really things. And you can fix it if you really want, right? So you can say if I is 1 or if I is 2, then that's a special situation. Why don't we do it? I'll do a special thing. So copying and pasting. And this would be first. And then if I is 2, then that would be second. Of course, that doesn't cover 22nd, which is left as an exercise. So this, and then this would be the else. So now you have this big block that gets repeated for I equals 0, I equals 1, and so on, up until I equals n minus 1. Make sense? Yeah, there was a question somewhere around here. No, you're good? Okay. Anywhere else? Yes.
Why does range not last?
Why is that's so the question was, why doesn't range go up to n, and why does it stop at n minus 1? And the answer is you have a choice, right? One choice is you repeat n times, and the other choice you go up to n. You cannot do both if you also want to start from 0, right? So the way to think about it is it starts from 0 and it repeats n times, which means that it must go up to n minus 1. There is going to be a more elaborate answer in a few slides as well. Yeah.
So if you wanted to go from 0 to 15, you could say in range n plus 1.
Yeah. I mean, yeah. So like if you wanted to go up to n inclusive, you would say range n plus 1. Yes. Yeah. Okay. Other questions? All right. So that was that. So we have done this. So there is, in fact, a more general mechanism that you can use. So you can say for I in range, and maybe that's kind of the fuller answer to your question. So you can say for I in range, start, end, and then step. And what that would do is it would set I to be start, and then start plus step, and then start plus 2 times step, and so on. And again, it would go up to the end, but not including the end. The default step is just 1. So that's what we saw before. So in particular, with the default step where you don't specify what it is, where you just say, where you just say for I in range start end, it's going to be start and then start plus one and then start plus two and so on. And you go up to, but not including end, which means that you go up to and including end minus one. Okay. And that's a different way of answering your question from over there. If you want to start from one and you want to go up to 100, including 100, what you can do is for I in range 101. So I'll just do 11 and I'll print I, and that will print 1 up to 10. Make sense? All right. So to repeat what I said to you before, that works with the idea of for I in range n, repeats it n times. It also sets I to 0 up to n minus 1. 0 up to n minus 1, including n minus 1, is exactly n lines or n values. All right. Let's do an example where we're using the I in a kind of substantive way that's not just I'm telling you for the I time. So this is kind of a common example, not something that you compute that often, but the factorial. How many people know about factorials? Most people. Okay. Well, now it's everyone because a factorial is like what's on the slide there, right? So in fact, all of you should have put your hand up because you should be reading the slides. So n factorial is 1 times 2 times 3 and so on up to n. So let's say that we want to compute that. How would you do it? It's actually quite similar to, well, there's the rigor, whatever. So it's actually quite similar to those functions. So the difference between my power over here and factorial is that inside my power, I multiply by the same thing every time. Inside factorial, I want to say times 2, times 3, times 4, times 5, and so on, up to times n. So that's what I'll do. So I'll say result is 1 because I want to be multiplying 1 times 2 and so on. I want to start with 1, not with 0, because 1 is the thing that makes sense. So here I'll say for I in range. So I want to do times 2, times 3, and so on, up to times n, including times n. So I'll start with 2 because 1 is already there. And I'll go up to and including n. So I'll go up to n plus 1, not including n plus 1 in steps of 1. So this is just going to be range 2 n plus 1. You can think about it as 2 goes into I, 3 goes into I, and so on, up until but not including n plus 1. And then we multiply result by I every time. So the only difference is here, we do 8 times 8, 8 times 8 times 8. Here we do 1 times 2 times 3 times 4 times 5. And at the end, we return result. So one fun fact about factorials is they grow extremely, extremely fast. So if I just try to print factorial of whatever, 1000, that is factorial 1000. Yeah. All right. I will see you Friday. Thank you very much. Bye. Start project 1, please. Bye.
You mind me asking about like unit testing, like,
Okay.
like, what would you say is the standard, like, building like industry, like, quality applications? Because, I'm working on like a project
Okay.
and like, I learned unit testing and
Yeah.
integration.
Yeah.
But I don't know how to like balance testing with actually like developing. I'm like.
I mean, like, look,